Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop an application powered by Intel's Neural Chat large language model. So we're going to develop this investment banking chatbot. So this is going to be a question answering bot for the investment bankers. So we're going to have a couple of documents, PDFs, and we'll implement a retrieval augmented generation. Kind of a system here, and we're going to leverage Intel Neural Chat 7B. You can find out Intel has now come in play when it comes to large language models, and you can see we're going to rely on Neural Chat 7B version 3. So they have version 1, which is fine-tuned on Mosaic MPT 7B, but this particular version, which is the version 3 of it, okay, you can see fine-tuning on Habana Gaudi 2. This model is fine-tuned on Mistral. It has been further fine-tuned on Mistral, and that's what we're gonna leverage. Not the exact same model, because we're gonna build this completely on a CPU machine, or even you can run it on a GPU machine on a limited hardware, kind of a limited virtual RAM. And I will cover a lot of details in this video. This is going to be a lengthy video, so if you are not a fan of like watching complete video and you want to go and jump into the code is available on my GitHub repository. You can find the link in description. But if you really want to learn a lot of new things that I'm going to cover in this video, please watch the video till end. Now we're going to develop this app, investment banking chatbot, and we have some details that this is a RAG implementation using open source stack. We're going to use everything open source. We're going to not use any closed source or API based services. Okay, so we're going to use BGE Embeddings by Beijing AI Academy. We're going to use one of the best open source embeddings model right now according to the leaderboards. We're going to use that to create embeddings of our source data. We'll use a vector store, Chroma DB. And there's another option that if you watch my previous video, I have used Qdran to self-host the vector database locally through Docker. You can also use that if you watch my previous video and combine with this. Now here we're going to use Chroma DB as a vector store, and then Langchain and CTransformers as an orchestration framework that's going to orchestrate our workflow. Now this is what the app will be built on top of this like tools. And here you can ask a query. So let me just ask a query. For example, I'm going to ask how is, let me just ask this, and I'm just going to hit enter, and you can see it says processing. It takes around 30 to 35 seconds on my CPU machine, and this latency will depend on what kind of compute power if you have. If you have a GPU machine, it will be even faster. It will take around 4 to 5 seconds to give you or generate responses on a good GPU machine. If you have some A100 or V100 or A10 GPUs, it will be even faster. Now, the reason I am building it for CPU, because if you build it and make it work on CPU, you will be able to make it work on any other kind of like computational devices. Now, the reason I want to cover in this until I get the response, I'll show you. Maybe let me open the terminal. You will see it says entering new retrieval QA chain. Okay, so let's wait for that. Now, Intel has now 2 or 3 different variant of neural chat, okay, that has been hosted on their Huggingface repository, and people are claiming a lot of things about neural chat. But let me tell you, if you look at this version that I am going to cover, that especially all the Mistral models, starting from Mistral to models which have been further fine-tuned on top of Mistral, have higher tendency of hallucination. And I don't recommend this model, to be honest. Okay, in production setting, in enterprise, and mainly for regulatory industries, closed source model still leads the race, and they still are winning that race when it comes to hallucination rates. And this is not who is telling you. This is also have been shown by Vectora. Okay, so if you look at for example here on Vectora hallucination evaluation model or whatever, right? I just come here. I don't know if they have the GitHub repository over here. I want to show you the leaderboard. You can see the leaderboard over here, which has been hosted. Now, if you look at this leaderboard, I'll make it a little bigger so you can read here. You'll find out the models. For example, you look at the Google models, which performs really bad, when it comes to hallucination. And I have my personal experiences with Text Bison and Chat Bison, one of the worst LLM, to be honest. I'll be honest with my my subscribers or people who are watching this video, okay, don't fall in the realm of small language models or open source model and putting in the production for your clients to do a business transformation. It's not going to happen. That's the reality, at least at this moment. For you and me, a small language model can be 350 or 500 parameter, but for Microsoft, who comes with Orca, for them it's 2 3 billion parameters. So please make sure what you are really talking when it comes to small language model. It should be enough small at least to perform the task, right? 7 billion model is a small language model. When you compare that with GPT-4, which might have a trillion parameter, you never know, right? So those are the things that we'll discuss in some other videos. But if you look at the hallucination rate over here, you'll find out that Mistral has almost double digit when it comes to hallucination. And even Llama does better, it has around 5% if you look at the 70B model, and 5.6 the 7B model. So what I'm just trying to tell you that if you go ahead with Mistral based model, you should you will see some kind of hallucinations, okay? And there are different techniques that we all control. I have different videos of how to control the hallucination rates through different techniques and approaches while building RAG. So make sure you choose your LLM in a right way and looking at all of your different like these parameters. Now coming back, we have our answers here. You can see the question was, how is GAAP accounting different from tax accounting? And the answer is GAAP or whatever. GAAP is accrual based, but tax is cash based. There is a difference between depreciation methods, straight line versus accelerated, complexity level and focus on assets, liabilities for GAAP, and revenue expenses for tax accounting. We gives you the answer. So the way I have programmed this, that it will return the answer to you if you are an investment banker or if you are preparing for an investment banking profession, and if you have a lot of questions that you can interact with it and you can generate or find out your answers. Now it also gives you the context. You can find the context. It gives you the page number, that from which page number and which documents. You can find out this is the document that it has retrieved the information from. You can find out the source document which has 400 questions. Let me go to that folder data, and you can find out I have two documents. One document name is 400 questions and technicals. The other is WSP Redbook sample. Now let me open that 400 questions and answers. You can see it's by Wall Street. And it has been, I have downloaded that from internet, and I have used these two documents as source documents because I wanted to keep at least two documents, not a single document. Most of the RAG performs well for a single document. Now if you come down, you will see that how many pages are there. There are around 90 plus pages in this document, and the other document also have some good number of pages. So we have created a vector store using Chroma, etc. And you can find out over here. And if you look at here is a gap. Okay, so these were the question that I asked. How is gap accounting different from tax accounting? And you can find out gap is accrual based, but tax is cash based. And you can find out the exact page number which has been retrieved by the system that we have built. So the RAG implementation is working fine for at least this particular question. And you can find out the answer which is really concise, and you can customize this with temperature or max new tokens or max tokens, whatever, right? You can control this further. Now this is what we're going to build this, guys, in this video, this good looking investment banking kind of a question answering bot where you can interact and ask questions that will generate answers with some kind of context and source document. So it has traceability. You can trace the responses. You have some explainability on the model response, not on the LLM explainability, but the RAG explainability, that from which part of the document the RAG of that entire workflow that we have, the retriever and the LLM generated response, how it has retrieved the response from which document, which page number, etc. Now let's build this application. We're gonna use BGE Embeddings, Chroma DB, Langchain CTransformers, and Intel's newly released Neural Chat large language model. So let's start our adventure with the coding, guys. Alright, so you can see I have a folder here that's named Neural Chat, and I'm gonna open this in terminal. I already have a virtual environment, but let's first open this in VS Code. So I'm just gonna open this in VS Code, and in VS Code we'll write all of our code here. And if you see, let me just also cd vnv scripts and dot slash activate. I have a virtual environment and couple of cd dot dot to get out, clean this, and that is fine. Now we have our setup ready to write some code. And if you look at here, I have a model called Neural Chat, which is a K-medium model. Okay, so it's a 4-bit quantized model from the Bloke Huggingface. I will give the link of the model in description, and let me also show you. So here is the Bloke repository by our Tom Jobbins. The credit goes to him for whatever he does for LLM quantization. Now you have to come to this repository. I will give the link in the description, and you have to click on these files and versions. Once you click on files and versions, you will find out the different quantized LLM variants over here. Now, starting from 8-bit quantization, which is higher in the hierarchy, and it also takes more compute power, but will of course be better in performances. And then you have 2-bit quantized. I will go with 4-bit medium quantized model, which performs better. It's not the best of course, but it does the job. So you can see it says 4.37 GB, and I will recommend this model if you are on right for example 16 GB CPU kind of a memory or whatever you are working with. That will help. If you have 16 GB RAM, you can go ahead with this. Now this is the model we're going to use, and it's fine tuned on Mistral, which have a higher tendency of hallucinations. Please be aware of that. Now what I'm going to do is I'm going to first create a file called ingest.py, where I'm going to write my code for ingestion. The first thing I'm going to do is import OS, and from Langchain, or let me just do one thing. I'll go to my GitHub repository, okay, and AI anytime GitHub, and I will go to my recent repository of, I have a JFR repository where I can take the embeddings code. So you can see I have a video also on JFR, or which is 7B beta RAG demo, where I created a video on JFR and all of the open source stack. Now, I love open source, by the way. Now, in the ingest.py, you can see that I'm going to copy this code entirely because this is what I'm going to use. I'll make a few changes here, but let's get that. So let's see what are the changes that I have to do. So I'll just do a Control G, and I will make that. So first thing that you can see, we are using an embedding model, BGE large embedding, large English, EN for English, large, and BGE. It's by BGE AI Academy, one of the best performing embeddings model right now. I recommend this. Okay, when you want to create embeddings of your data. Now I am on CPU, and that's on my model quarks. The encode quarks normalize embeddings. Let's keep it false, and then we are just creating that embedding variable. Now here I'm going to make the change. Right now I don't have a single file, I have a directory, and I want to load this from directory. So for that I'm going to make a change here. So let's do that. What I'm going to do is from Langchain dot document loaders, and this is going to be my uh, directory or something. Okay, directory loader. Okay, and you can see the imports. Let me explain the import. The operating system, you're going to split the text. For that, we need recursive character text splitter, which will have the chunking strategies. For example, chunk size, overlap, blah, 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 right? Now you have your vector stores. You can use any vector store or vector database you want. Chroma, Pinecone, Waviate, Milverse, blah, 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 right? Again, the choice is yours. Now, I have a lot of videos on vector databases. You go ahead, watch those videos and use any other as if you want. Now we are using BGE embeddings. You can also use sentence transformer directly from directly the sentence transformer class. You can also do that. Then we have directory loader and PyPDF. Now here I'm going to make the change. So let's do that. So from loader, I'm going to do directory loader. And in the directory loader, I'm going to pass my folder path. And then we'll have globe. And for that, I'm going to have in globe, I'm going to have that where double star. Okay, so asterisk. And I'm just saying that, okay, only look at the PDF part of it. Only look at the PDF extensions. So if you have Word, you have to pass docx, doc, whatever. If you have CSV, if you have Markdown, you have to pass MD. Let's also pass, what should we pass? Let's pass the progress so we can see in the terminal. So progress equals to true, which is a Boolean value. And let's also pass loader class. I'm going to pass PyPDF. I want PyPDF to be used as a backend pre-processing library to load the PDF and process the PDF file to extract data. That's what I'm defining over here. Now this is how my loader gets changes. Now everything looks nice. We have a chunk size of 1000. Sorry, I fished a power cut, guys, but that is fine. Now, if you look at the loader class, which is PyPDF, now here we have directory that takes that variable, load the file, and then we have recursive character text splitter defining a chunking strategy, a very basic one, having a chunk size of 1000, having a bigger chunk size so it can capture more information from the extracted text, and it has a chunk overlap. So for how many chunks it should overlap, so 100. Now, text splitter, we are splitting the documents. Now, in the vector store, we are using chroma.from documents, passing the text, passing the embeddings model, and in the collection metadata, we are defining that HNSW space cosine. You can pass IP, you can pass dot, you can pass cosine. So it has Euclidean, it has dot, it has cosine, different kind of algorithms that it supports, as a that how it should perform your vector similarities. You can define that in that as a collection metadata as well. Okay, while it creates the embeddings, update the vectors if required, and all of those things. Okay, that you can define. Now, um, I'm also gonna store that in my disk, and I'm saying persist directory, so it will be in memory. So it's an in-memory vector store, and let's make the change the name here. I'm gonna call this as let's call it banking cosine or something like that. Okay, now I'm gonna save and let's run this, guys. So what I'm gonna do is python ingest.py, and once I run this, it will take a bit of time to create the embedding. But let me show you what happens. Now once I hit enter, python ingest.py, first a model will be loaded, this embeddings model. If you're running it for the first time, it will take a bit of time. It says PyPDF is not defined, and that's okay, we have PyPDF loader, so let's use that. Okay, so I'm going to use PyPDF loader, but you can also use PyPDF. As I've imported PyPDF loader, that's what I'm going to do. Now let's run this again, python ingest.py. Let's see. So if you're running it for the first time, it will take a bit of time for you, because then it has to download the BGE embeddings model weights from Huggingface. That's what it's going to do. Now you can see we have a show progress equals to true. Now you'll see that the folder has been created. Let's see that folder. And it says chroma.sqlite3. When Chroma became popular due to due to the generative AI, how it evolved, nobody knew Chroma before that, by the way. Okay, now so Chroma evolved at that point of time. They were on DuckDB. Okay, so they were using DuckDB, Parquet, etc. But they migrated to SQLite a few months back. I feel that's a good way of also scaling up. I think that was the right decision to migrate from DuckDB to SQLite, and I think that's why you see a chroma.sqlite3 here. It will also create a folder with some IDs that you will see, and it will have all of your embeddings in some n-dimensional space that you will see there. So it will take a bit of time. Let me just show you. You can see it's now cursor. You can see on the here, right? It's blinking. It means it's creating your vector store. Let me pause the video here because it will take a few minutes. It might take from a minute to 15 minutes to 30 minutes depending on how many files that you have and how big your data corpus is. So let me pause the video here. I'll come back once it gets done. As you can see now, our vector store has been created. You see it says vector store created. That was the print statement. And now we have our own vector store built using Chroma, where you will have your SQLite, and then you have your bin, data level, header, length, linked list. And we have that, our vector store now. So our embedding part is done. Okay, and that has happened offline. You can do it in real time as well if you want to do that for few documents. Now let's create an app.py where we'll write our code. Okay, now on my GitHub repository that you will see, I have created two different files, one using FastAPI and the other using Flask. I wanted to, because I have recently noticed that FastAPI, I don't know what's really happening. It's really slow when it comes to building microservices or APIs kind of a thing, and that's why I was evaluating, and Flask was a bit faster in my several testing that I did with for the same RAG. Now let's build that. So what I'm going to do is I'm going to open my GitHub gist here. Okay, and I'm going to use a few piece of code that I can use it that I already have used in my previous videos. This is not the first time that we are creating a RAG videos. I have at least 10 plus RAG implementation using different LLMs techniques, how to build better RAGs. merge ranking, re-ranker, a lot of other things. Now let's get the imports first. So I'm just gonna copy this here and paste. You can see it's the Flask one that I'm building. So we have from Flask, import Flask is a Python library, helps you build backend services. Now you have your import Flask, request, justify, render template. Render template will help us. Oh, from render template, I remember that I have to create two folders. So let's create static. That is wrong. Let's create static and templates. So let's create templates. Inside templates, let's create index HTML. Now we'll take index HTML from our repository, but first let's go back here and let's also right click back to GitHub. Now I'll open your profile repository and I'll go into templates to take the index HTML file, and I explain that on very high level. This is the front end that you might not be that interested in, but if you can build it in React, you can build it in Next as well. Let me first explain what's happening here. Okay, so if you look at, we are using Bootstrap 5.3. Over here you can find out Bootstrap 5.3. So the front end is built on HTML, CSS, Bootstrap 5.3 and vanilla JavaScript. No frameworks other than Bootstrap 5.3. But if you want to use React, you can use React to build. If you want to use Angular to build, you can do that. Now we have a bunch of CSS classes, bunch of CSS that styling that we have done. You can see, and this is where our div starts. So we have a container layout in the middle of the page, the layout that you saw in the beginning of the video. We have given this a name of this class as chat container, where we style this container. Now it has an h1 header which has investment banking chatbot, has an accordion which is a collapsible accordion. In that accordion, what we are doing, we are describing the app description, the RAG, etc., and all of those things. Okay, now about this app RAG implementation, then we have input box, user input. You can see it's a form control. So form, type your query. Let me do an alt G so you can read it better. And then we have a button, and then we have a JavaScript function. So if in JavaScript, if you see what we are doing, we have the get element by ID, which looks at the user input every time you put an input and hit the button. So it will have an ID there, and that's what it does. And then it uses, you can see, it uses fetch. So fetch is a method in JavaScript that helps you, integrate your backend with the front end. You can see it says await fetch. We are doing a post method because we are putting some questions. So it's a form, and we are making a post request there. Using fetch await, we are going to interact with the backend with the front end to retrieve the response. And then if response not respond dot okay, throw error that network response was not okay or whatever if it's not working. So this is the conditional. And you have source document, we are doing something for source document, etc., error process, and then we have error processing, so some kind of exception handling and all, right? So this is what we are doing on the front end, that you might just skip this part. You already have the code on GitHub. Now on app.py we have important. So let me just do an app equals Flask or something. That's how Flask name, and then you also do if name, something like that. Okay, if name main, and here you can define your app and all of those things. Let me just plug in my charger, and here you can do a few things. So you can do app.run, and in that you can pass the debug equals to true. If you find out if there is any error, it will show you on the interface itself, so you can debug it right there. So let's do debug equals to true. You can also define host. So my host is localhost, so it will be 000, and this is going to be like this, and then you define port equals to 5000. So it runs on, excuse me, it runs on port 5000. Now in between this, you're gonna write your code. Okay, in between this we are writing our code. So we have initialized an app, and now we are running that app. Now for that, let's go back to my GitHub again. Okay, let's go in the Jeffer demo itself. Okay, and let's go to app.py. And here you can see we have something called local LLM config, at least till prompt template. This looks nice, embeddings looks nice. Prompt, blah blah blah. Let's get it till embeddings. So I've copied this piece of code just to save some time. I'll explain that what's happening. Now you have to see that I have a local LLM, so I'll just change this name here. Okay, so this is not going to be Jfur. This is going to be Neural, Chat and 7B, your model name V3. Always download the model locally, guys. That's a better way of doing it. v.q4, and you can see now it has suggested me. I will delete everything before this. Now this is my model. Now I have my local LLM defined. Now this is my LLM. Now I have some config as max new token says 1024. Excuse me. Have some temperature 0.1. Let's make it more creative. So 0.2. Have top K, top P. These are all standard that has been recommended by CTransformers, the creator of CTransformers, Marela on GitHub. You can find out and start that. That's really helpful. Now in the LLM here, we are using the CTransformers class. Okay, you can find out we are getting it from Langchain.llms, and then we are passing all of those parameters like model names, the model type, the library, which is AVX2 for my CPU, and then passing the config. Now it has a print LLM initialized. I have a prompt template. Now in this prompt template, it's a very basic prompt template that we have. You have seen it in a lot of different uh, a lot of different RAG implementation where you define your context and question, and it only returns the helpful answer and nothing else. You can customize this prompt template completely, and then we have our model name, the embeddings thingy over here, the model name, the BA large embeddings, the same thing. Now here, let's first do something. So I'm going to call my prompt. So for that, I'm going to use prompt template, and in this prompt template, I'm going to pass my template. So template equals, so excuse me, template equals prompt template. So that template is done. Now we'll have two input variables. So in input variables, what I'm going to pass is a list. So in the list, I'm going to define my input. The first thing is context, and the second thing is question. So we are done with our prompt, guys. Now, so prompt is done. Let's load the vector store. So what I'm going to do is load a vector store. So let me just load the vector store, and how are we going to load it from Chroma? So once you create an embedding, at that point of time, you have to do Chroma dot from documents, because you are creating embeddings. Now once you are loading it, you don't have to define dot from documents, only Chroma. So from Chroma, and here I'm going to pass my persist directory, the name of my vector store where I have stored that. So you can see it is stores, and then what we have, what was it? So we have that banking cosine. So let's do that. So this is what I'm going to do. So banking cosine. Okay, now persist directory have been done, and then I'm going to pass my embedding function. So embedding function. So embedding function, and my embedding function are nothing but the embedding. So let's do that. So this is what embeddings are. Now I have loaded my vector stores. So after vector store, once you load it, you're going to have a retriever. So let's have a retriever variable, and I'm going to define load vector store dot get ret as retriever. Not get retriever, as retriever. It's a Langchain class, and in as retriever, I'm going to pass a parameter called search quarks for how many top K document I want to search. So for this purpose, I just want to keep it one. So search quarks, and let's keep that one. Okay. Search quarks, and it's a dictionary. So K equals K colon 1. That's how we do. So you have your retriever set now. Okay, so now you have the retriever, and you can just create a RAG chain. Okay, to leverage this, a retrieval QA chain, by the way. Sorry. Now you can do a retrieval QA chain. So now let's define a few. Let's first get app a route, a decorator, because we're going to use the Flask method. And here I'm just passing this. And let's write a function for index HTML file. So define index. And here I'm just going to do a return render template that I have imported on top. And here I'm just going to pass my index HTML. Now, if you go to my Jfur thingy over here, right, this is going to be the same. we'll use this same response, retrieval QA chain and all of those things. Now for that, what I'm gonna do is I'm going back to my not GitHub. Let me go to gist. Your gist. I already have that Flask part. I'm just gonna copy this Flask part. Okay, so let me just copy. I'll explain that. What are we doing here? Now, if you look at this function, nothing fancy. We have a post method that we are defining. In Flask, you are defining post method. FastAPI, this will be a little different, and the code is available on my GitHub repository for FastAPI as well. Now, here, if you look at get response, this is an API endpoint. See this as an endpoint that you will hit on port 5000 once you hit the submit button on that, and then you just do request form that get query, and we have a chain type where we are passing prompt equals prompt. Then we have QA, retrieval QA from chain type, passing the LLM, which is our LLM, which is defined here. You can see in line 26. That's what we are defining here. Then we have a chain type, which is stuff. It provides different type of chain type, like map, re-rank, stuff and refine, etc. Depends on what kind of use cases you are solving. If you are working on a summarization, you will probably work with a refine kind of a chain type and all of those things. If you are working on knowledge graph, you will work with map, re-rank. So there are different way you can select chain type. Stuff is better for question answering kind of a use case. For that, I have a chain type. Now retriever is retriever. You can find it out in line 59. Then I'm also saying return source document true because I want to do a bit of traceability of the output. And then my chain type quarks, which we have been defined here with the prompt, and then verbose equals to true. Then we use this QA variable, pass our query that we are taking from the end user. You can look at here in line 67. And then just parsing the output, guys. We have response, getting the result. From the list, it's a list. We have that values of element result. We are getting it. Then source document, page content, metadata, and then returning everything because it has to be a JSON serialized object. That's what we are getting here. You're going to JSONify here and responsing the data. Now this is what we have done, guys. Now let's run this and see what output we are getting from the piece of code that we have written. So to run this, let's open this in a terminal. So open in terminal and let's go VNV scripts, activate that /activate, couple of cd dot, clean this, and let's do python app.py. Once I click on python app.py, I think it will, and you can see, right? So let's open this in localhost 5000. And you can find out it says investment banking chatbot. Okay, so you have a very slick interface where you can put your query. It says type your query here and you can retrieve some information about your source data. So 95% of the use cases in industries are same, guys. It's knowledge retrieval. So you have some kind of database. It can be audio, video, images. It can be multimodal kind of data, and you have to basically build a system that will either interact with it, having some conversational memory. You can chat with it with human-like response, or you can build a query engine where you retrieve information. And now you can build use cases across two industries, but your underlying concept is same. Now here I'm just gonna ask some questions. So let's ask this question. What does or let me ask this question. This looks good. So it says, let's go back to 2004 and look at Facebook back when it had no profit and no revenue. How would you value it? So I am asking this question, which is, it also has the dates. So LLM struggles with dates. Okay, so dates and numbers. There are some, LLMs are famous for that, that they struggle with this kind of situations where the dates are involved. Let's see how it gets it for this one. Now, I have asked this question that when Facebook, like in 2004, when they started, let's go back to 2004 when they were working on the Facebook, the app, whatever, when it had no profit and no revenue. So how would you value it? So if I am an investment banker and if I have to value Facebook on their 2004 period, how will I do it? And I'm asking this to an AI. Okay, now think like that. Let's see what it responds. Now, if you go back here in this, it says entering new retrieval QA chain. So it has entered into a retrieval QA chain. we are using a Flask thing. You can see it says this is a development server, do not use it in production deployment, use a production W, and we got our answer, guys. Fantastic. Now it took around 30 seconds to 35 seconds. It's pretty fast, to be honest, if you compare that with other models, okay, on the same bracket. Now if you look at the response, it says you would value Facebook based on other methodologies such as comparable companies, precedent transactions, EV unique visitors, page views. You would not predict its cash flow for that year since it had no profit or revenue at the time. So I got a very concise response. It also gives you the context, and it also gives you the source document from which it has retrieved the information, which is fantastic, right? I mean, this is really good. You can see the exact same thing it has got from this particular context of the document, and I got my answer, and this is really cool. And I know this is the right answer, to be honest. So how do we evaluate that? Can we do it quickly? Let me do a control F, and can I search about Facebook here and see if there's any thing here? And you can find out the exact 16 contexts. So the retriever works fine, that retriever that we have from Chroma, that works fine, and that retrieved chunk gets to the, like, we feed that retrieved chunks to a large language model. So how the RAG works, you have an embedding vector store in n-dimensional space, then you have a retriever techniques that retrieves that first using BGE embeddings and from that Chroma vector store, and then that is fed the top k equals to 1. So there's only one chunk, so you can do top k equals to 3 or 5 depending on the context window. Now you have 1, you pass that to an LLM, and then LLM looks at the chunks and synthesize that response to give you a human-like response. That's what it does. So you find out the answer over here, which is fantastic, right? I got my answer. Let's ask the other question. So we'll see what kind of question we can ask. Okay, let's ask this question. Okay, what does it mean or something? Okay, now I'm asking this question here. Let's ask this question and submit. So right now this app does not has conversational memory. You can use conversational memory kind of stuff. You can extend this further. I would love to collaborate with you if you are doing it. I would love to hear from you, by the way. Okay, if you are working and extending this further, putting us better techniques like re-ranking, merger ranker, LOTR, etc. into this for a better RAG with a self-hosted vector database like QDRAND, for example. You can look at my previous videos on QDRAND, Waviate, and a lot of other vector databases that we have worked with. Now let's wait for this answer and see what kind of response we are getting for this. Now the code will be available on the GitHub repository. As I said, this one we have done it for Flask. We also have done it using FastAPI, okay, where you can use FastAPI, which is better than Flask, which is more scalable, and you can find out the answer. It says, in reference to bond prices, discount means lower price with greater yield. Par indicates the price equals 100. Yield is equal to coupon, while premium implies higher price with lesser yield than coupon. It gets the context, and right now you see that the source document is changed, and this is what I wanted to see, because most of the time LLM only retrieves from the first document or something like that, right? You have document, it only gets to the first document and retrieves. Now it looks at the other document as well. So we have two documents. If you look at the other document, let me go to inside data. We have this WSP, Wall Street Preparation. It's an investment banking interview questions. If you are an aspiring investment banker, you can refer to this kind of documentation. Now let's see that. So we have this context over here, and it says data. Let me ask this, for example, what can I do? Okay, par indicate. So let me see that. Where is that? Okay, so let me search. Par indicates. Oh, it says no. So let me just do only par. It says parent company, but it will be somewhere. So let me just do hit. It's looking at comparable. Or maybe I am not searching the right keyword there. Let me look at in difference to bond prices, discount means lower price with greater yield equals 100. Let me put 100 and see if I get something. Perfect. I got it, right? So look, what does it mean when a bond is trading at a discount, par, or premium? I think that was the question here. You can look at the question and it gets the right answer. It says 100, a coupon, while premium, blah, blah, blah. We get it, right? Fantastic from this context. So now it's working perfectly fine, but let me ask a question, and on this I want to evaluate. Now if I ask a question, who is Donald Trump? Let's see if it answers it. because right now we evaluated that it is working from both the document, it's giving you the right response. We'll ask a final question about Donald Trump and see if it's, and I don't know why it's always Donald Trump that I pick, but let's see that. I'm asking about Donald Trump. If it gives the response, it's not the LLM fault, it might be my fault that I'm not handling the prompt template in a way that it should stick with that. Maybe a better validation can be put in place that will act as an extra validation layer that will not go to the LLM's base knowledge, and you can find out. It gives you the response, and that's where it fails. It says Donald Trump was the 45th president of the United States, which is correct, by the way, but it gives you the context which has nothing to do with it, and that's what problem with these RAGs are right now, right? And the LLMs kind of, but there are other validation. I have a lot of videos on evaluating RAGs, how to build better RAGs and validations. You have to bring all of those techniques to scale this further, but this is what I wanted to show you in this video, guys. I hope you learned something in this video. This video might be a bit lengthy, but I've covered a few things with complete open source stack. We are not using any API services. Now the entire code base is available on GitHub. If you have any thoughts, comment, feedbacks, please let me know in the comment box. If you like the content, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel. It will help me create more videos in near future. You can reach out to me through my social media channels. Those are available on my YouTube banner and the channel About Us. Thank you so much for watching. See you in the next one.